For the last couple of weeks, all the hype has been about Kimi K2.5, which is the most powerful open source model till date, coming in at a massive 400 billion parameter scale. It's natively multimodal and great at software engineering tasks as well as tasks like puzzle solving, recreating stunning websites from just a video, and much more. But the real catch is that Kimi K2.5 doesn't just attribute this to their modestly huge model size, but to something called scaling out. You see, how they have solved this is by introducing something called PARL. And in this video, we will be understanding how PARL works and what makes it so efficient at visual agentic intelligence. Simply put, PARL, or Parallel Agent Reinforcement Learning, is a system that allows Kimi K2.5 to be a wolf pack instead of a lone wolf. Most AI models try to do a complex task sequentially. Step 1, then step 2, and then step 3, and so on. Now that method is inherently slow. PARL allows the model to look at a huge task and break it into tiny pieces and say, you, 100 agents, go do this all at the same time. This reduces the time it takes to finish a job by up to 4.5 times. To really understand how the math works, let's step back for a moment and start thinking about this in game terms. Imagine a game called Agent Swarm. You play as the commander, which in this case is the orchestrator agent. You're the only character in the game that can gain points and level up, which means that you are trainable. And the goal is to defeat the big boss, which means the goal is to solve the complex task. The game mechanics is that you have a special button called Spawn Clone. When you press it, you create a subagent. These clones are frozen, which means they can't learn or level up, which means these agents cannot be trained. They just spawn, do a specific task or a subtask, and then disappear. In the beginning, the game is hard. The commander gets scared because he doesn't know if the clones will actually work. So he stops pressing the button and he tries to fight the big boss all alone. This is called serial collapse, where the AI reverts to doing everything by itself because it feels like delegating is too risky. So how did the developers fix this? They hacked the scoring system. This is where the actual math comes in. Look at this equation. This is their staged reward shaping function. Let's translate this into gamer terms. See that lambda ox part? In the early levels, this number is really high. It means that the game gives you points, which is R parallel, just for pressing the spawn clone button. It's like a participation trophy. The game is literally saying, good job, you delegated this, and I don't care if you miss the clone or miss the target, just keep spawning the clones. Now comes stage 2, which is at high levels, the lambda ox drops to 0. Now the spawn button doesn't give you any points. In fact, it gives you 0 points. The score, our success, only goes up if you actually kill the boss, or which means you actually solve the complex problem. The game takes away all the training wheels and you only get rewarded if your strategy actually solves the problem. But there's one more rule. The developers didn't want you to just spawn a million clones for no reason, which means the orchestrator cannot create 100 different subagents just for no reason. They introduced a speedrun timer called critical steps. Here is the equation for the timer. Now in a normal game, the timer counts every second that you play. In Agent Swarm, the timer works differently. S main is the time you spend thinking. Max I or S sub is the time your slowest clone takes to finish the job. This means if you spawn 50 clone, but one of them gets stuck against a wall for an hour, the entire speedrun is ruined. Spawning more clones only helps if it actually shortens the critical path, which is the total time to victory. So why is this architecture so important? Well, because it solves the biggest bottleneck in AI right now, which is coordination. We have models that can code and we have models that can see. But PARL gives us a model that can manage and orchestrate. It gives us a single smart model and makes it into a coordinated factory of agents. Kimi K2.5 proves that if you train the orchestrator correctly, first with participation trophies, then with stricter goals, we can unlock a level of speed and complexity we haven't seen in agentic systems before. And that was it. Thanks for watching. If you want to dive deeper into equations, check the description for a blog post, and don't forget to like and subscribe for more deep dives into LLM architectures.